plus 8x plus 64. What would your guess have been? You all guessed it would be negative 8, right? What made you make that guess? Jashin? Square root of 64 is 8. And then you notice that we always did the opposite, right? Everybody cool? Okay, not quite the opposite, but it was negative 5 when they were both positive, and it was positive 4 when one was negative, right? Okay, now I just told you that you would be wrong there, wouldn't you? Because negative 8 squared is 64. 8 times negative 8 is negative 64, right? 64. 8 times negative is negative 64. 64 plus negative 64 is 0 plus 64 is 64. So it can't be that, right? So it's not enough just to have the square root there. See if you can spot another part of this pattern. Again, look at the answer and look at the entire equation. Remember, the answer to the first one is officially that. Can you see any other patterns? Liam?
The answer is usually mostly second number divided by 2.
Excellent. You take the second number, divide it by 2, and do what?
And reverse the sign.
Not quite. Because the second number, 10, divided by 2 is 5, but I needed 25. What did I have to do to that 5 to get it to 25? Square it. Now let's see if that follows all the way through. What's half of 6? What's 3 squared? 9. What's half of 14? What's 7 squared? 49. What's half of negative 8? Negative 4. What's negative 4 squared? 16. What's half of negative 18? Negative 9 squared? 81. Half of negative 20? Negative 10 squared? Positive 100. Everybody see the patterns? So, I'm going to do something here that we're going to write this out in general terms. Now, you guys have all heard that phrase already. You've heard me making the joke about it in grade 10, except for 3 of you. As soon as I say general form, I say major form or yes, sir. You all remember that joke, right? There's a general form here. The general form of a quadratic equation is ax squared plus bx plus c. And remember, a, b, and c are just numbers. X is a variable. Everybody cool? This is the general form of a quadratic. Polynomials, a trinomial is polynomial 3 terms. Why we call these quadratic equations perfect square trinomials? What is it about these guys that allow us to use that term? So, C is a perfect square. And what did Liam notice about B? B divided by 2 is what? The square root of C. And why we call them perfect square trinomials is because they always factor to that. X is the square root of x squared. The square root of c there, and I get the same thing, right? Because here I had x, square root of that was x. It ended up being x plus 5 all squared. Right? Does everybody see this pattern? Everyone's cool with it, yeah? Yeah? So if I give you this, x squared plus 16x plus 64. What's the answer? X equals what? Negative 8. Right? If I gave you x squared minus 12x plus 36, what's the answer? X equals positive 6. Everybody cool? Yeah? 100%? Okay, what if I gave you 16x squared plus 24x plus 9? Why did you know these two were negative 8 and positive 6? What'd this guy become? X plus 8, or x plus 8 squared, right? What'd this guy become? X minus 6, or x minus 6 squared, right? What's this guy going to become? 4x plus 3 squared, which means x equals negative 3/4. Everybody cool? I'm a little nervous that you can see this right away and you can't see this one. Tell me what the similarities are between that and that. Are they both in general form? Excellent. Okay. Why were you able to do this one immediately? What did you do? You notice these two patterns, right? B was the square root of C divided by 2, or times 2, right? B divided by 2 was 8. 8 squared was 64. So we were able to do this, right? Then we did the same thing here, right? Everybody's cool? And then that gave us this piece of knowledge, correct? Right? We took the square root of the first one, which was x, the square root of the second one, which was the square root of 64 is 8, and we ended up with x plus 8 squared, which we then know is x plus 8 equals 0, so x had to equal negative 8, right? Okay, if it happens once in math, how often does it happen? Always. So this had a perfect square here and a perfect square there, right? Right? Yeah. Does this have a perfect square there? Does it? Is that a perfect square? So does it not make sense that we could try this move? Square root of the first one, square root of the second one, square root of the first one, square root of the second one? Everybody cool? And then, of course, why this works is because 4x plus 3 would have had to equal 0, which meant 4x would have had to equal negative 3, which would mean x had to equal negative 3/4. Is everybody with me to there? By now. Everybody's got it. Even if you can't do it in your head, you can follow all this math. Basically, I'm saying if you factor it out and you get two of the same factor, you're in good shape. Yes? Okay. So, here's a bunch of blank space, yes? Which means we're going to write something down. So, if we are going to solve by completing the square, x squared plus, let's go with, Let's go with 11. 121 plus 22x equals 0. If you hadn't seen anything yet today, and I faced you with this, what would your first step be? Factor it, right? That's the first thing you would do. Okay, so if we're going to solve by completing the square, because that's what we're doing right now, step 1 is to factor, right? So let's factor. X squared, so I need numbers that multiply to what? 121 and add to what? 22, right? Which gets me x plus 11 times x plus 11 equals 0, which gets me x plus 11 squared, right? And the reason this works is because this is a perfect square trinomial. So this is already a completed square. Does everybody follow me? It's already in a form that is complete. Is everybody good? And now, if I were to ask you to write down in this space right here 3 more perfect square trinomials, could you do so? Do it. Write 3 perfect square trinomials down in the little corner. I just want to make sure everybody's on the same page. I'm going to write a couple myself. Everybody okay? What are some of the ones you people have? Somebody give me one.
X squared plus 24x plus 144.
24x plus 144. Absolutely correct. And the answer is, of course, x equals negative 12. Right? Who's got another one? Liam.
X squared plus 12x equals, or plus 36 equals 0.
36 equals 0. Absolutely correct. And the answer is 6. 6? Negative 6?
Oh, I also said plus 12x.
Oh, okay. I didn't hear the 12x. Okay. X squared plus 12x plus 36. And that's perfect, yes. Everyone is good? Remember, what's the key? I had a perfect square at the beginning, I got a perfect square at the end, and that middle term works nicely, yes? Okay, so everybody could do that, right? What is wrong with what I'm about to draw out here? What's wrong with that? Does that start with a perfect square? Sure does. Does it end with a perfect square? Sure does. So why isn't it x plus 6? Because that is ugly, correct? Right? Okay. And all that would equal 0. Agreed? Now you're intelligent young people. If this was 25, could we do it? We could, couldn't we? But it's not 25, is it? It's 36. Are we allowed to manipulate equations? Are we allowed to move them around and mess with them? Yes or no? Sure we are. As long as we do what? What is the key facet to an equation? Noah? You have to do it to both sides to keep it equal, right? So, what would happen if I moved that over there? What would happen? It would be negative 36, wouldn't it? Are we still okay? Now, if I put 25 here, can I work with that now? But if I add 25 to there, what must I also do there? I must add 25. And that, ladies and gentlemen, would mean we could now factor this and carry on forward. Agreed? How did I know to use 25? I saw that pattern. If I half that and square it, I get a perfect square, don't I? So let's turn the page over and let's have a look at this. First of all, I want to talk about what GDC means. That means a graphing calculator. We're going to use them later. We're not going to use them now. We're going to do all this the old school way. So let's look at this question. Up till letter A here, we have always had a quadratic. And what does it equal? It's always equaled 0, right? Noah knows that. And what did we do? We do what we always do. We factor. And then we get an answer, correct? Okay. How does that remind us of that? Do they look fairly similar? What's the only difference? There's a 5. Everybody agree? If that 5 was 0, what would you do? What would you do if 5 was 0? If it was that same trinomial, but it equaled 0. What would your first instinct be in your second year of math? It would be what? It would be to factor it, right? You would take this side and you would factor it. And what would it factor down to, Sarah? Would it be negative? Would it be positive? It would be, as a factor, it would be that, right? Everyone agrees? But would we write that like that? How would we write that? X plus 7 squared would equal 5, correct? Everybody follows me to there, right? What's our final goal whenever we see an X? Isolate it. How would we isolate that? What's in the way of X being isolated right now? There's a squared, because this is a base, isn't it? If I had X squared equaled 81, what would you do? I'd square root both sides. So what am I going to do here? Square root both sides. What's the square root of X plus 7 squared? X plus 7 equals, if I square root one side, what do I got to do this side? Square root. So then I got the root of 5. Is X isolated? What would isolate X? Minus 7, or moving that over, X equals the root of 5 minus 7. Does everybody see what we did? Is that a math class answer or a real life answer? Math class answer. What are we in? No. We're in math class. So is that the answer I want? Is that the answer I want? Or do I want some stupid decimal that goes forever? That's the answer I want. Now all of you do that for B. Because it's nothing new. Everybody cool? All right, now, can we forget our old math? No, of course not. Remember when we talked, what does that squared mean the line will look like if I graph it? What shape does it make? A U. Right? Where are the x values? They're along there, right? And I want the x values where y was 0, right? So, how many of them are there? 2. But when we did our math, the math we knew how to do, it only gave us one x value, didn't it? But I know there has to be 2. Where in this part did something go wrong that eliminated one of the answers that we need? At the square root. Why? What is the square root of 25? Is it only 5? It's plus or minus 5, isn't it? So what is the square root here? It must be, is it just square root 5? What is it really? It's plus or minus the square root of 5. Plus or minus the square root of 5. Which now allows me to have 2 different x's. Is everybody cool? So, the math you knew how to do got you to here, but then that new math that we showed you, how this line curves, so there has to be 2 x answers, means what must I have here? Not just plus 6, what must I have? Plus or minus 6. Because once I do a square root, it's plus or minus the square root. Is everybody with me? Yeah? All right. So now, take us to here and tell me, actually no, let's make sure everybody can do this. You guys do one more. Let's make it x squared minus 14x plus 49. What would that be for a real answer? Now that you know all the tricks. Oh, wait, and that equals 12. What? Yeah, of course it can be flipped. Order doesn't matter. It could be plus or minus root 6 plus 3. That's why I did the root first here and then the root second there. So remember, if that was 0, what would we do here? Of course, Rhea. What would we do here? Factor. What is it? X minus 7 squared equals what? 12. And then what? Square root x minus 7 equals what? Plus or minus the root of 12. And then what do we do with the 7? 7 plus or minus root 12. Is everybody good to there? Okay. What's different here? What's different in the next one? What's different in A? What's missing, Isabel? It's not a trinomial. I got x squared plus 10x equals 6. Now, if I add a number there, do I know what to do? And if that number makes a perfect square trinomial, do I know what to do? Okay. Am I allowed to put a number there? Yes, as long as what? I do the same thing to the other side. So, first thing I look at is, wait. First thing I look at is, do I have a square trinomial? Do I? No, I don't. I only got a binomial. So yes or no? No, I don't. So I need to make a perfect square trinomial. Now we've just done 20 of these. What do we know we can put there that will make this a perfect square? What did we do to the b term? I divided by 2, and then what did I do? Squared. So, if I have a perfect square trinomial, if it's a yes, let's make a flow chart. If it's a yes, I factor. And then I solve. Just like we did up top, right? What if it's a no? Then I go to step 2, which is I make a perfect square trinomial. How? By, what do I do to b? What do I do to b? Divide by 2 and square it. Now, I will make a perfect square trinomial, correct? So then, I can bring my flow chart back up to here where I factor and solve. Everybody good? Let's try it. So this is what I am starting with, correct? What is half of 10? What's half of 10? What's 5 squared? 25. So I am adding 25 to this side. Is it equal anymore? What would make it equal? Adding 25 to the other side. So now I have what? X squared plus 10x plus 25 equals what? 31. Now do I have a perfect square trinomial? Can I go back to the start of my flow chart? What do I do with that perfect square trinomial? Factor it. What is the factor? X plus 5 squared equals 31. X plus 5 equals plus or minus what? Root of 31. X equals negative 5 plus or minus root 31. And that is what we call an exact answer. And that's what I want. What does physics class want? The decimal. Negative 5 plus or minus square root of 31, which is about 5.3, right? So it's going to be negative 5 plus 5.3, which is 10.3. Negative 5 plus 5.3, which is 0.3, or negative 5 minus 5.3, which is negative 10.3. Everybody with me? We're in math class. What do I want? Exact. Everybody cool? Everybody cool? I don't want you to try the other two yet. We're going to remind ourselves what to do. Step 1, factor if possible. Step 2, make a perfect square. How? B divided by 2 squared to both sides. 3, factor 4, isolate x. Is everybody good? Let's try B right here. And we'll do C underneath this box. You guys will do C. So I've got x squared minus 12x equals 3. Do I have a perfect square trinomial? Do I? No. Even if I move this 3 over here to make a trinomial, it's still not perfect square, is it? I've got no perfect squares, so I got to make one. So this is going to equal 3. And I've left a blank there because that's where I'm going to put in what I need. How do I know what to put in there? I think to myself. What do I think to myself? I'll do the Mrs. Bag Crumble Cloud. B divided by 2 squared. What is it? What's B? Negative 12. What's half of B? Negative 6. And what's negative 6 squared? Then I think to myself, what do I got to remember over here, self? I got to add the 36 to both sides, or what's going to be screwed up? My equality is screwed up and it's no longer equal. So what do I get here? I got x squared minus 12x plus 36 equals 36 plus 3. X minus 6 squared equals 39. X minus 6 equals plus or minus root 39. X equals 6 plus or minus root 39. And am I done in math class? Am I done in physics? No. The root of 39 is a little bit more than 6, right? So it would be 6 plus a little bit more than 6, which would be 12 and a bit, yes? Or 6 minus a little bit more than 6, which would be like negative 0.3. Everybody cool? Joran. I'm sorry, what? It depends on how much work you need to show. If you do a whole page of these and every answer is wrong, are you showing enough work? Can I help you with where you go wrong? If you don't show me? There you go. You show as much work, as always, as you need to show. If you choose to show me no work, and your answer is anything other than this, and it's out of 4, what am I going to give you? 0. So you choose. Now, let's do the third one down here. X squared minus 3x minus 1 equals 0. Is that a perfect square trinomial? No. It's a trinomial. So I got to make it a perfect square trinomial, don't I? So I'm going to move that over there. And now this looks like what I'm comfortable with, yes? Everyone agrees? Okay. What do I need to do to B? Divide it by 2 and square it. What's wrong with this one? You can divide 3 by 2, but what does it give you? A decimal, and we hate decimals. But even though we're scared of fractions, they make us run into the woods screaming, there's no need to be. Because 3, is that not B divided by 2? And then square it. What does that get me? What does that get me? 9/4, right? Plus 9/4. So what do I got to add over here? 9/4. Now, factoring this, we already know what to do, don't we? Because everything we factored was half of that became the binomial, didn't it? So isn't this side just x minus 3/2 squared? We're happy with that, right? And it equals, what's 1 plus 9/4? Exactly, it is 1 9/4. There's no need to be scared of it. How do I make that into something I can work with? What do I do with 4 and 1? What do I do with 4 and 1? Multiply, and then what do I do with 9? Add 13/4. And now, can I do this? What do I do to this side that's squared? Square root. X minus 3 halves equals plus or minus the root of what? 13 fourths. What do I do with this 3 halves? Move it over. X equals 3 halves plus or minus the root of 13 fourths. And guess what? We're in math class. Do I get to leave it? Yes. So the thing that you were all scared of gets to stay there. Everybody understand? Now, some of you are still scared by that. Let me make it so it doesn't scare you. 1.5 plus or minus the square root of 4.25. Easy peasy, right? Yo. No. Everybody cool? Sweet. Let's see what happens. Let's have a look at these. Why did I leave this blank here? I'm going to put something there. But what is my first step always? What should my first step always be? Factor, factor, factor. What do you notice about that, that, and that? They can all be factored by what? 2, giving me what? X squared plus 4x equals 3. Now what goes there? Why is it 4? 4 divided by 2 is 2. 2 squared is? Once I add plus 4 to that side, what do I got to do over here? Plus 4. And I get x plus 2 squared equals 7. X plus 2 equals plus or minus root 7. X equals negative 2 plus or minus root 7. Everybody good? Terrific. What's different about B? It's scary pants time. What's different? There's no GCF across the whole thing, is there? So what could I do? Where is there a GCF? I want to make sure I'm not screwing you guys over. Could I do this? Can I do that? Is that okay? Oh, sorry. I should have taken out a 3x. Is that okay? Don't write this down. Is that okay? It is, right? Okay. Does that help us? I'm trying to complete the square, yes? What did I just do? I factored out the 3x, which did what? Does that complete the square or does that remove the square? It removed the square. Damn, son. Okay. So that's no good. Do I have other options? Just take the 3 out. Oh, that's a little better. If that 3 wasn't there, would I know what to do? What would I do right there if that 3 wasn't there? What would I do with the 5? I'd divide it by 2 and square it, right? Well, let's see what happens. Everyone agree? 5 squared, or 5 over 2, is 25 over 4 squared, yes? Okay. Did I add something to this side? What did I add? 25 over 4 times 3, which is what? 75 over 4, right? 2 plus 75 over 4. 3, what happens here? Look at all your previous work. What was it, Noah? Damn right it's 5 over 2 like it was in all the previous ones. And what's this? Well, isn't 2 8/4? So isn't this 83/4? Are we cool? Now, does that 3 bother us still? Bothers me. How do I get rid of it? I divide by 3, and now I've got x minus 5 over 2 squared, right? What do I got to do to this side? Divide by 3. Isn't that the same as multiplying by what? 1/3. 83/12. Now, does this look exactly like that? Yep. What do I do? Square root both sides. And I'm done. Once again, has the math changed at all? No. Sometimes we added fractions, but we all know that 7 divided by 2 is 7 over 2. And we all know that 7 halves squared is 49 over 4. Right? So, to complete the square when the coefficient of x squared is not 1. So we are looking at ax squared when a doesn't equal 1. And what's one way we just did it? 1, we factor out a. Just a. It's not GCF, it's just a. Everybody cool? Is there another? And then we follow what we know. Now, I want to ask you something. Could I get rid of the 3 at the beginning? Do you think it'll work? How would I get rid of that 3 right now? I know. How would I get rid of that 3 right now? I could divide that 3 there, I could divide that 3 there, and I could divide that 3 there, couldn't I? Then I would get x squared minus 5x equals 2/3, yes? Does this look like something we can deal with? It would be x squared minus 5x plus 25/4, yes? Equals 2/3 plus 25/4, yes? 25/4, what's the common denominator there? 12, and when I do the math, I'm going to come out with 83/12, aren't I? And then it's the same. Who decides when to get rid of that 3? You do. If you don't mind adding fractions and finding common denominators, knock yourself out. If you don't like doing this, this freaks you out, do it this way. You decide. So I either A, factor out A and follow what we know, or I can divide all by A and then follow what we know. But please notice, grade 4 is back, isn't it? Because when did we learn that? Grade 4. Yeah, that's when you learn to add fractions. Unless you're from another country, then of course you learned in like kindergarten. Remember what I warned you about at the beginning of the year? Can you forget anything? No. Every piece of math you've ever had is back. Look at those first 6. Tell me just by looking, what are the 4 that are going to be really easy?
3, 4, 5, 6.
So I've heard 3, 4, 5, 6. Okay. And you think that because they already equal 0, yes? All right. Does anybody wish to change that? It isn't that. There are 4 of those that are really easy. What did we have to do no matter what method we chose? What did we always have to do? We had to what, Avni? We had to make it a trinomial, which meant doing what? What did we have to do to the b term? Divide it by, and then square it, right? What's easier to divide by 2, evens or odds? How easy are those going to be? Pretty easy because they divide by 2. What are those going to do to us? They're going to make us write fractions. And what do fractions make us do? Run screaming with scant bladder control. So, what should we start with? We should probably start with 1, 3, and 5, yeah? Go. Do 1, 3, and 5. See if you know what you're doing. You guys try them. I'm going to... Yep. Now, I know that a lot of you probably aren't done those first three. Just going to wait a second, let you puzzle out at least one more of them. I want you to see the right answers before you head off. And try 2, 4, and 6, which are more difficult. You do 1, 3, and 5 first, because they're the easy ones. Because they are even. You did the fraction ones? That's cool. All right. Does anybody have an answer for me for number 1? Anybody? Liam? Yes, absolutely right. -4 plus or minus root 19. Does anybody have an answer for 3 for me? Sarah? 3 plus or minus the root of 8. Absolutely correct. Does anybody have a third one for me for number 5? Isabel? Absolutely correct. I'm going to turn the screen on. And the only change I'm going to make is I'm going to tell you that one of those 3 could be further simplified. Which one? Green, blue, or yellow? I'm telling you right now, I'm happy with all of these, but one of them gets you to that spot of true math understanding. Which one of those can be simplified further? Because they're all the right answer. Sarah? The blue one. Why? It's not a cube root. What can I do to root 8? 2 root 2. Because 8 is 4 times 2, right? Now, on this, the first day, do I sweat a detail like that? No. Fast forward 3-4 weeks, because we've got 2 weeks of spring break in there. We're at the end of the quadratics unit. Do I expect that tidied up? Yeah. Everybody with me? All right. Now, it's 2:06. I want you to attempt tonight. You are going to attempt tonight 1, 2, 3, 4, 5, 6 on page 78. And for the rest of class, you're going to try 2, 4, and 6 here. You'll see the right answers to 2, 4, and 6 in a moment. Because I'm going to do them right here. And they'll be recorded on the video so you see it step by step. You're going to be practicing it right now. Everybody good? Go.
Put that into a calculator and you put the other one in the denominator. Get off my face. Get off my face.
Okay, ladies and gentlemen, it's 2:10. I'm going to let you work at your own pace until 2:18. Then I want to show you the right three answers. And then I want to talk about where you would go from there. Meaning every one of these three answers simplifies further, but I only need you to get to here now. Everybody okay with that? All right, go. Simsalabim. There are the answers. Of course, you might have, for this bottom one, negative 1/2 plus or minus the root of 13/4. And if you have those three things, I'm very, very happy. Now, just to let you know, this guy right here, 5/2 plus root 37/4. What is the square root? This is really 5/2 plus root 37 over root 4. Yes? Root 4 is really what? So it's 5/2 plus root 37/2. So it's 5 plus root 37. Plus or minus root 37. I forgot the minus. Over 2. That's the best answer to clean up that square, that radical in the denominator. Everybody understand? If you get to here right now, okay, I'm over the moon. I literally am turning cartwheels if you are here constantly. If you want to get to that next little bit that you're going to need to get to if you go further in math, make sure you're aware of how this turns into this. So this one right here would be negative 7/2 plus or minus the root of 65/4, which is negative 7/2 plus or minus the root of 65/2, which is negative 7 plus or minus root 65 all over 2. And this bottom one is, of course, negative 1 plus or minus root 13 all over 2. Is everybody cool? Now, the homework I'm asking you to do is 6 questions. Remember, they apply to these guys. The top of page 77 is where you'll find how to do these guys. Six questions for homework. Will there be? I don't know. So if I don't know, you don't know. So what's the best thing you can do for yourself? Do it anyway.